Okay, again, what we're looking at here is we've got a function, y equals x cubed, and we want to know, okay, what did we do to y equals x cubed to turn it into y equals 3x minus 2 all cubed plus 1? And again, we can probably have a little bit of a guess at it, couldn't we? We reckon we're moving it to the right 2 units, probably moving it up 1 unit, and there's a dilation there of some kind. But what I want us to do is, again, let's go through it in a more structured manner so that we can apply these transformations to anything. So I think the easiest step here in this one is let's consider the graph, the new graph, which is y dashed is equal to 3 times x dashed minus 2 all cubed plus 1. Yeah? And what we want to do, that's my new y graph. We want to get that into the same form as y equals x cubed. So that means I'm going to take the 1 across, subtract 1 and divide by 3, and that's equal to x dash minus 2. So if I compare this to y equals x cubed, we can make a direct comparison between those two values and those two values. So from this I can see that in fact y is equal to y dashed minus 1 on 3 and x is equal to x dashed minus 2. Now, so it's sort of just working in reverse a little bit. So what I want to do now is, okay, let's work out what x dash and y dash are. So therefore, what is y dashed? If I consider this top equation, I multiply 3 across, add 1, I get y dashed. And for the second equation, if I take 2 across, I'll get x plus 2 is equal to x dashed. Because now what I can say is that x dashed y dashed is equal to x plus 2 and 3y plus 1. And with it in this form, I'm thinking it will always be relatively easy to identify the transformations. So what is this plus 2? If I add 2 to the x value, it's a translate 2 units in positive x direction. And if I consider the y values, I've multiplied the y value by 3. So it's a dilate by 3. Now, if the y value gets multiplied by 3, I'm moving it from the x-axis. And a plus 1 is translate 1 unit in positive y direction. Okay, so what the process is I'm concentrating on here is getting it into a format that we've been working with already, and that once we get it into sort of this format here, I'm hoping we're going to say, okay, if I add 2 to the x value, I move it 2 units to the right. If I multiply the y value by 3, I move it away from the x-axis. And if I make, add 1 to the y value, I translate it or I move it 1 unit in the positive y direction. All right. So that's my process. That's what I want us to work on. Look at that graph 2. Now we want to get y equals the square root of 4x plus 2 into the same format as y equals the square root of x. So my new function graph is y dashed equals 4x dash plus 2. And it's nearly already in that format, isn't it? Okay, so from here, if I compare the y values, I can see that y is equal to y dashed. And if I compare the values under the square root sign, I can see that x is equal to 4x dash plus 2. So once I've got that, means that y dashed is equal to y, and x minus 2 over 4 is equal to x dashed. So I get the coordinate x dashed y dashed is equal to x minus 2 on 4, comma, and y is just the same. Now let's think about, I could write this now as x over 4 minus 2 on 4, which is a half. All right, which depending on how you want to describe your transformations, you might describe them slightly differently. So I'm going to give our translations in two different forms here. So we'll call this form 1. And in form 1, what are we doing? Well, clearly I've got my x value, I'm moving it, I'm subtracting 2 from the x value, so translate 2 units in negative x direction, and then I'm dividing that whole thing by 4, aren't I? Or if you like, multiplying by a quarter. So then I'm multiplying the x value by a quarter, which means I'm dilating from the y-axis, which means I'm dilating by 1/4 from the y-axis. Yeah, so don't forget, say there's my square root graph there, and if I multiply by x value by a quarter, I move the x value by left or right, depending on whether I'm making it bigger or smaller, okay? So I'm moving from the y-axis. I could possibly, okay, if I want to describe it as number 2, do the dilation first. I am going to dilate by, well, again, I'm multiplying the x value by a quarter, multiply by a quarter, dilate by a factor of a quarter from the y-axis, and then I'm going to translate half a unit in the negative x direction. So you can see how, depending upon the order that I describe things, I get slightly different descriptions. For the most part, we tend to use this one here, okay? And that is, we tend to do our dilations and reflections first, and then describe our translations. So more than likely, it's form 2 that is the description in the back of a book sort of thing, all right? If by chance we had a test, both answers are correct, all right? All I would say to you is that you've got to be confident that if you want to do it the green way, that you can recognize that the blue statement is exactly the same. So in a multiple choice kind of situation, you can see that the blue statement is the same as the green statement that you were thinking, and hence it's also a correct response. All right. Let's have a look. Last one. All right. Now this one is exactly the same, all right, except in this case, I'm starting with what we would consider to be a transformed function and turning it into my original function or my standard function. So again, let's start with, well, I want to get them both at the same form so I can compare them. So what do I need to do? I need to rewrite this equation here, which is my original y. I want to subtract 5 and divide by 2, and that will be equal to 1 over x minus 1 squared. The other equation is y dash is equal to 1 over x dashed. Oh, they're all squared, sorry. not cube, I think what I said cube, I'm not sure. Okay, so notice this time, as it turns out, I'm rearranging my original equation. So my little dashes always go with my new function, all right? So in this case, I've got y dash, and that is equal to y on 2 minus 5 on 2, and x dashed is equal to x minus 1. So as it turns out, I've already got my x dash and y dash, haven't I? So let's go in this section. So I can say then that the point x dash y dash becomes x minus 1 y on 2 minus 5 on 2. Okay, and again, I could have left it in this form here, couldn't I? So what are my series of transformations? Typically, any dilations and reflections first. So let's dilate. What's happened to my y value? It's got multiplied by a half. By a factor of a half from, now if my y value gets affected, it's from the x-axis. And then I've got some translations, and then I can translate. What's that, a minus 5 on 2 it is, so translate negative 5 on 2 units, or actually let's make it a 5 on 2 in negative, so if my y value is being subtracted, it's in the negative y direction. And what's happening to my x? I subtract 1 from my x, so let's translate 1 unit in the negative x direction. All right. So that's how I turn 2 over x minus 1 all squared plus 5 into 1 on x squared. Does it kind of make sense? Well, this is 5 units up, so I want to head down. Okay. Now I'm talking about going down 5 on 2 units, but we remember that's because of that dilation factor. I'm 1 unit to the right, so I need to go 1 unit to the left, which is what I'm talking about there. So it kind of makes sense. I think we've got it the right way around. So this one, very similar. So we've got our starting with y equals, so let's turn it, take the 2 across, y plus 2 equals 3x plus 1 cubed. Compare that to my new graph of y dashed equaling x dashed cubed. All right, so we can equate our terms. I can see then that y dashed will equal y plus 2, x dashed will equal, or x dashed equal 3x plus 1. And I've already got my x dash y dash is equal to 3x plus 1 y plus 2. So now I can list my transformations. So the x value gets multiplied by a factor of 3. So I get a dilate by factor 3. Now if the x value gets multiplied, it's from the y-axis. And then we translate 1 unit in positive x direction, and then we translate 2 units in positive y direction. Okay, and again we can sort of give it a quick check. We're negative 2 down, so I expect to be able to move up, which is good. I know a plus inside the bracket means the original graph is to the left, which means I need to move to the right to get it back to the starting point. All right, let's leave it there.